June 30, 1908, the Podkamennaya Tunguska River area in Siberia, now known as Krasnoyarsk Krai, experienced a massive explosion in broad daylight when a fireball blazing through the sky struck a remote part of Russia. Before we continue telling you about the Tunguska event, subscribe to our channel for more interesting videos like this. Local farmer Semen Semenov reported seeing the sky split in two. Over the forest, fire could be seen rising and spreading. Strong heat emanated from the area where the fire was. Then the skies suddenly closed, there was a loud thump, and I was launched a few yards. After that, there was a loud roar, like cannons firing, and the earth trembled. This is the horrifying account of one of the closest eyewitnesses to the Tunguska catastrophe, which experts refer to as the biggest cosmic body impact in the course of contemporary human history. Nearly 65 kilometers, 40 miles, from the explosion site, Semenov experienced a blazing conflagration, but Northern Europe and Central Asia also felt the consequences of the catastrophe. Others observed luminous skies at night. Londoners, for example, could clearly read newsprint at midnight without the use of artificial lights. Some people observed huge, silvery clouds and gorgeous, colorful sunsets on the horizon. Geophysical observatories identified a remote region of Siberia as the origin of the unusual seismic and pressure waves they had observed. The Podkamennaya Tunguska River, which flows through an uninhabited swampy taiga forest that is frozen for 8 to 9 months out of the year, is near to where the epicentre was located. Since the Tunguska disaster, both experts and casual observers have pondered its origins. No one has yet discovered any asteroid or comet debris or impact craters in the affected area, despite the fact that most witnesses largely agree that some sort of cosmic body, either an asteroid or a comet, exploded in the sky over Siberia. The mystery is still unresolved, but our research team, only the most recent in a long line of sleuths who have searched the area, may be getting close to making a finding that will alter our perception of what took place that tragic morning. Because earlier encounters with extraterrestrial bodies have significantly impacted the evolution of the Earth, studying the Tunguska catastrophe is crucial. For instance, a planetoid the size of Mars appears to have hit our young planet 4.4 billion years ago, scattering enough material to form our moon. And 65 million years ago, the extinction of the dinosaurs may have been brought on by a significant impact. There are still visible effects from space. Several astronomical observatories captured the stunning impact of a comet on Jupiter in July 1994. And only last September, Peruvian residents witnessed a celestial object shoot across the sky, land nearby with a tremendous boom, and leave a gaping pit that was 13 meters wide and 4.5 meters deep. Peter Brown and his colleagues at the University of Western Ontario and Los Alamos National Laboratory calculated the frequency of smaller impacts using satellite observations of meteoric flares in the atmosphere, also known as shooting stars, and acoustical data that records cosmic impacts on the Earth's surface. The researchers have also generalized their results to more significant but uncommon occurrences like the Tunguska explosion. Asteroidal impacts similar to the one that occurred in Tunguska occur on average every 200 to 1,000 years. Therefore, the possibility of a similar strike happening during our lives is not remote. Fortunately, the Tunguska hit occurred in a remote area of the world. If something similar were to go off above New York City, the entire metro region would be destroyed. Understanding the Tunguska incident may enable us to take precautions against similar occurrences and maybe prevent them altogether. Determining whether the cosmic object that impacted Siberia was an asteroid or a comet would be the first step in preparing ourselves. Even though the results are roughly the same in both scenarios, there is one significant distinction. Comets, which orbit far from the Sun on long-period orbits before returning to Earth, would strike the planet with much greater velocities than asteroids, which orbit close to the Sun on short-period orbits. Thus, a comet that is far smaller than an asteroid might provide the same amount of kinetic energy in a collision of this kind. Additionally, it is far more challenging for observers to find long-period objects before they reach the inner solar system. Additionally, the likelihood of such objects crossing the Earth's orbit is modest in comparison to the likelihood of asteroids doing so. These factors make proven comet impacts on the planet uncertain at this time. As a result, If a comet was indeed responsible for the Tunguska catastrophe, it would be a singular occurrence rather than a significant case study of a well-known category of occurrences. On the other side, why haven't any asteroid debris been discovered if an asteroid explosion did occur in the Siberian skies that morning in June? The explosion's massive amount of energy nearly destroyed 2,000 square kilometers of the taiga forest, uprooting 80 million trees in the process. Even at a distance of 60 kilometers, some people were simply blown off their feet while others felt the blast's heat. Witnesses report that the entire northern sky appears to be engulfed in flames. At that very time, there was a great smash and a bang in the sky. Following the crash, there was a sound similar to falling stones or gunfire. This Tunguska event produced around 185 times more energy than the Hiroshima atomic bomb, making it the most potent of its sort ever recorded in history, with some estimates coming in even higher. Even in the UK, seismic rumbles were noticed. Despite being such a significant occurrence, it received very little media attention at the time. The harsh environment of the Siberian region and Russian policy are likely to blame for the same. Only a few neighborhood newspapers reported on it before a Russian team commanded by Leonid Kulik made a trip to the region in 1927. Even 20 years later, the damage was still largely evident. He discovered a vast area of flattened trees in the shape of a butterfly and suggested that it might have been caused by a meteorite crash, and that the remnants of the meteorite eventually were buried due to the swampy grounds. Later, it was suggested that a comet, not a meteorite, was to blame. Since comets are composed of ice, this explanation explains why there were no meteorite remains to be found. When it was suggested that it was the consequence of a collision between matter and antimatter, the theories became even more fascinating. Other theories put it down to a nuclear explosion and an alien ship crashing at the location where Lake Baikal was looking for water. More absurd explanations were proposed, and finally the discovery of nickel and Lonsdaleite led scientists to conclude that the object might be a meteorite with some evidence to support the hypothesis. However, none of the aforementioned theories could be accepted as the sole explanation for such a massive event, since meteor showers occur frequently on Earth and cannot be taken for granted as the primary factor. This is not the end of it, and some later proposals even attempted to link Nikola Tesla's research on magnetic coils for wireless energy transmission to the Tunguska event. The Tunguska event was a highly unusual instance of what scientists refer to as a megaton event, as the energy emitted was equivalent to 10–15 megatons of TNT or possibly more. This is what made the event so dramatic. Although it was a once-in-a-millennia occurrence, mankind still don't know what caused the devastating explosion. If you want to watch more stories like this, please consider subscribing to our channel.